times y plus 5 equals 0. So that means my y either equals negative 3 or my y equals negative 5. Since I flipped it, I changed it to y squared. My y is now my input, so I'd put that on the x-axis just like we would do anything else. We're all in the negative direction, so I'm going to do something like that. 1, 2, 3, 4, 5. That's negative 5. This is negative 3. I put my points here, here. We know it opens up because there's a positive 1 in front of that y squared. So it looks something like that. And I'm looking for when it's less than or equal to. So less than is this portion. So I am going to have the bracket negative 5 to negative 3. And we are done. That's all the work you need to do for this one. Questions on that? Questions on the homework? Pablo. Number 6. So the huge problem with number 6 is you end up having to actually graph it. You actually have to graph it. Because if you try to solve it for it equaling 0, so if I did my negative x squared minus 9 equals 0, it'd be pretty ridiculous if I plugged that into the quadratic formula. So instead of doing anything like that, I'm just going to move the 9 to the other side, which would give me negative x squared equals a positive 9. Divide both sides by negative 1, I'd have x squared equals a negative 9. And if I would then take the square root of both sides, I'm going to realize it has no real zeros. It has no real zeros. So we have two possibilities. It never crosses the x-axis, so either it's going to be kind of up here, or it's going to be down here. Well, since there's a negative up front, it must be the second one. It must be that it's going down like this. And if you took the time to actually plot our vertex would be at 0, negative 9, which would be about here, and it would open down. You know what's another great way to check that one? These awesome devices that can graph everything for you. Calculators. I've been telling you, graph these on your calculator. Because if you graph this on your calculator, you would already have the answer. You wouldn't have to plot it by hand or anything. And as I said, I'm most likely just going to let you use your calculators on the test because no one seems to be using them anyway. So if you're taking the time to actually learn how to use them, this problem's going to be super easy because you plug it in your calculator. You don't have to do any work. You can just see that it has no zeros, and you can just show that. All right, so make sure you're using your calculators. Tomorrow you need your calculators. Tomorrow you need your calculators. All right, other questions from the homework? No? All right. Then let's get to today's lesson. Today's lesson is going to be a lot of dividing polynomials. And we're going to start out with something called the remainder theorem. So remember when you first learned how to divide? If I would do like 45 divided by 10, it wouldn't go evenly. So that last number you had, you threw up on the top and said, that's my remainder. So I said it could go in like 4 times remainder 5. We didn't go to the decimals. We didn't go to the decimals. We just said it had a remainder of 5. Well, we're going to go back to remainders because we're going to divide a polynomial by another polynomial. And we're going to come up with this remainder theorem. The remainder theorem says if r is the remainder, so remember if like remainder 5 is, I'm done dividing, I have this extra number, that's what we're talking about. If r is the remainder when polynomial p of x is divided by x minus c, then p of c equals that remainder. I think the hardest part about this is this right here. Right now it looks a little fuzzy because we haven't done any examples, but you have to recognize if I divide by x minus c, I'm actually checking for plugging positive c into the equation. All right, so if I'm dividing by x minus c, I'm actually looking for positive c. So if I would divide by x plus c, I'd be looking for p of negative c equals that remainder. just have that written down. You'll know more about what's happening when we do some examples. All right, that first example says find p of 3 if p of x equals 2x cubed minus 5x squared plus 4x minus 6. We're going to use ordinary division, which is blah, and then we use synthetic division, which goes a lot quicker and is a lot easier. So we're supposed to find p of 3. So I'm looking for p of 3. In order to find p of 3, I need to divide by x minus 3. I need to divide by x minus 3. Dividing by x minus 3 is the same thing as plugging 3 into this equation. So we're going to divide that equation by x minus 3. And this setup is just like any other long division. We're going to have x minus 5 outside of a division bar. Inside that bar, we're going to have 2x cubed minus 5x squared plus 4x minus 6. Yes?
Where'd you get x minus 5?
Oh, I'm sorry, x minus 3. I don't know where I got that x minus 5 from, honestly. That is a great question. Because that should be that x minus 3. Once again, to see a p of 3, I'm going to divide by x minus 3. If this was p of negative 3, then it would be x plus 3. We switched the sign there. All right, so I have x minus 3 I'm seeing how many times it goes into this. Well, what we're looking for when we start off is all I'm looking at is that x and that 2x cubed. I'm asking myself, what do I need to multiply this by to make it equal to 2x cubed? And that is 2x squared. Because 2x squared times x gives me 2x cubed. Well, I can't just multiply by the first term. I also have to multiply by this negative 3. So we're now going to do 2x squared times negative 3, which will give me negative 6x squared. Here's where people make mistakes. When you're doing division, this next step is actually subtracting. Because if I was just to add these, I'd have 4x cubed, and now I'm making something bigger. So this step is actually subtracting. I'm subtracting that whole thing away. To give me 2x cubed minus 2x cubed gives me that 0. I'm not going to write the 0, but basically those just cancel out. And then we have negative 5x squared, and it's actually plus 6x squared because we distribute that negative sign. So I have negative 5x squared plus 6x squared, which equals x squared. Then we drop down that 4x. And we do it all over again. I look at this x, I look at this x squared, and I say, what do I multiply x by to give me out x squared? Well, that's just plus x. And that's because x times x would give me that x squared. Now I have to take that x and multiply it by that negative 3, which would give me negative 3x. Once again, you have to remember that you are subtracting. To give me x squared minus x squared, which would give me 0. So those would cancel out. And then I'd have 4x plus 3x would give me 7x. All right, the last thing is we have to drop down that negative 6. I look at that x, I look at that 7x, and I say, what do I multiply x by to give me 7x? So we are going to add 7 to this top. 7 times x is 7x. Then we do 7 times a negative 3, which is negative 21. We are subtracting. 7x minus 7x is 0. Negative 6 plus 21 is going to equal 15. That 15 is called our remainder. We're out of stuff to divide. That is my remainder. I'm also going to note that this 2x squared plus x plus 7 is our quotient. So we have a remainder, we have a quotient, and it asked me what does P of 3 equal? Well, P of 3 is going to equal the remainder. So P of 3 is going to equal that 15. And we'll check that down here. So what this is saying is if I plug 3 in to this equation, I'll get 15 out. Let's use synthetic division. Synthetic division is a little quicker, easier. So synthetic division, I'm going to still look for the same thing. I'm still looking for P of 3, which is really x minus 3. However, with synthetic division, I am just going to divide by a positive 3. So you either take whatever's in here, or you take the opposite of this. So it's the opposite of this. It is what makes this 0. So we're going to start with a positive 3. So I'm going to draw something that looks like that. Now, what I'm going to do is I'm going to look at my original thing. See how we have x cubed, x squared, x, and a constant? We're going to have different columns on this one. We're going to have, what did I say, x cubed started up? We're going to have an x cubed column. We're going to have an x squared column. We're going to have an x column, and we're going to have a constant column. Now we just have to list how many of each one we have. We have 2 x cubes. So right here, I'm going to write a 2. We have negative 5x squared, so I'll put a negative 5 there. We have 4 x's, and finally we have negative 6 for our constant. Synthetic division always starts the same way and is always the same process. The first thing you're going to do is drop that 2 down. Now what we're going to do, it seems kind of weird, because it's division, we're actually going to use multiplication. We are going to do 3 times 2 and put that result there. I'm actually going to write it underneath. So we're going to do 3 times that 2, and we're going to write that answer right here, which is 6. Now we're going to combine those two values. So I have negative 5 and a positive 6. Negative 5 plus 6 is plus 1. So we have a 1 there. Now we go back to this 3. Multiply it by this 1, and put that result right there. So we're going to do 3 times 1, and put that result right there. 3 times 1 is 3. Positive 4, positive 3, that's going to give me 7. Once again, we go back to that 3. I do 3 times 7. I put that result right there. 3 times 7 is 21. Negative 6 plus 21 is 15. Whatever number's at the end is our remainder. This 217 is our quotient, but it's not written in quotient form yet. Notice this is my remainder. That makes my next one my constant, my x, and my x squared. So in fact, every one of these columns actually drops a power. So rather than this being 2x cubed, this is actually going to be 2x squared. So the quotient is going to be 2x squared plus 1x plus 7. That's my quotient. I'll put a big Q by it. But really, I don't care about what my remainder is, because my remainder gives me my answer. And we're looking for P of 3 is going to equal 15. And that's from that remainder. So synthetic is a lot easier, a lot quicker, a lot less mistakes most of the time. All right, just to prove it to us, so I said when I plug in 3, I should get 15 out. So last thing we're supposed to use is substitution. So if we went back to where we're just plugging stuff in, I would do P of 3. I don't have it right in front of me. So we're going to have, instead of x's, we're going to put 3's. So I'll have 2 times 3 cubed minus 5 times 3 squared plus 4 times 3 minus 6, which if you do the math, it would come out to 15. So doing that division is the exact same thing as plugging in the number. You get the same answers. Whether it's synthetic, ordinary, or substitution, we'll get the same answer. All right, questions so far? I think the big thing is, when I'm looking for P of 3, with ordinary division, I'm doing x minus 3. If I'm using synthetic division, I'm just going to take that positive 3. Or if I'm given x minus 3, I have to change it to a positive 3 as well. Yes? Be careful, because if I say you have to, so look at the first 3 problems on the homework. The first 3 problems on the homework say use long division or ordinary division. All right, but a majority, so I might just give you one that I have to see your long division, and the rest will be use any division you want. All right, so like tomorrow we're actually using this to factor bigger things than, so like to the 3rd power or something. In those cases, I just use synthetic division because it's easier. So when we apply it, we'll use synthetic. Yes?
If there's no x cubed, do you just put a 0 in that place?
Yes, and that's what we're going to do on the next side.
Okay.
Quit rooting surprises, Lizzie. Now I can't be like, y'all did it wrong. No. All right, so Lizzie brought up a good point. We now have x to the 4th minus 14x squared plus 5x minus 9. We are supposed to divide by x plus 4. I'm going to add something onto this one. See how it says we're dividing by x plus 4? We're actually looking for P of negative 4. We're looking for P of negative 4, or where our function is if I input negative 4. All right, so we have x plus 4 we are dividing. We have to use ordinary division, then we get to use synthetic division. Whew. Good thing the bottom 3 are all synthetic division, or bottom 2. I think there's 2 more down there. We are going to divide by x plus 4. Like Lizzie said, we have to account for every power. If they give me an x to the 4th, I have to count for x to the 4th, x to the 3rd, x squared, x, and I have to count for a constant. So we're going to plug in x to the 4th. We do have to account for 0x cubes. Then we have negative 14x squared plus 5x minus 9er. And now I can do the division. This is long division, so it's going to take a bit, especially with how many terms we have. But same method. I look at my x, and I see how I'm going to turn that into an x to the 4th. So we are going to multiply by x to the 3rd. X to the 3rd times x gives me x to the 4th. X to the 3rd times 4 is 4x cubed. Don't forget you are subtracting. So we have x to the 4th minus x to the 4th. I have 0x cubed minus 4x cubed, so I'm actually going to have a negative 4x cubed. I'm going to drop down that 14x squared. I'm going to look back at that x from x to the 4th, and I'm going to say, what do I multiply x by to give me negative 4x cubed? Well, that must be negative 4x squared, because negative 4x squared times x is negative 4x cubed. Negative 4x squared times a positive 4 is negative 16x squared. We are subtracting. So that's negative 4x cubed plus 4x cubed. That's 0. I have negative 14x squared plus 16x squared, which is going to be 2x squared. Let's drop down that 5x. X times 2x. Oh, did I make a mistake? 4x cubed become negative. You sure?
Yeah.
I am kind of rifling through this. I should probably take a second. You sure? Okay. All right, so we are at 2x squared plus 5x. I'm asking, what do I multiply the x by to give me 2x squared? That's going to be a positive 2x. And that's because if I take that 2x and multiply it by that x, I would get 2x squared out, and that's what I wanted. So we have 2x squared here. I do 2x times that 4, which is going to give me 8x. But we are subtracting that. And so we're going to have 5x minus 8x, which is going to give me a negative 3x. We're almost done. I just have to drop down that negative 9 and finish this off. X times negative 3 gives me that negative 3x. So we're going to attach a negative 3 up here. Negative 3 times x is that negative 3x. Negative 3 times 4 is going to give me a negative 12. Whew. But we are subtracting. And so I'm actually doing negative 9 plus 12, which is going to equal a positive 3. Did we all get there in one piece? All right. So it does ask me, find the quotient and the remainder. This 3 right here is my remainder. This big thing here, that x cubed minus 4x squared plus 2x minus 3 is going to be our quotient. Bless you. So our quotient is x cubed minus 4x squared plus 2x minus 3, and our remainder is 3. I also know that p of negative 4 would actually equal 3. Didn't ask for it, but I know it. So p of negative 4 would equal 3. All right, synthetic division. Let's show how much easier it is to use synthetic division. So we are looking for x plus 4. With synthetic division, here's the big switch. I need to divide by a negative 4. All right, it is going to be negative 4. With synthetic division, it's what makes this 0. And that's going to be a negative 4. Now, we do have to account for all of our categories. So I have an x to the 4th to start off with. So I'm just going to go x to the 4th, x to the 3rd, x squared, x, and constant, because I need to account for everything going down. Well, x to the 4th, there's a 1 out front there because it's x to the 1x 4th. So we'll just put a 1. X cubed, there are no x cubes, so we'll just put a 0. X squared is going to be a negative 14. X's, we have 5 x's. And finally, our constant is negative 9. With synthetic division, I drop that 1 down. Then I take this 4, multiply it by the 1, and plug it right there. So that's negative 4 times 1, which gives me a negative 4. Now I combine these two numbers. So that's 0 minus 4, which gives me negative 4. I want to go back to black. Now I'm going to take that negative 4, multiply it by that negative 4, and put that result right there. So that is negative 4 times negative 4 is going to be a positive 16. I combine that negative 14 and that positive 16, which is going to give me 2. Then we're going to take that negative 4, multiply it by that 2, and put that result right there. Negative 4 times 2 is going to be a negative 8. 5 plus a negative 8 is a negative 3. And finally, we're going to take that negative 4, multiply it by that negative 3, throw that guy right there. Negative 4 times 3 is going to be a positive 12. Negative 9 plus 12 is going to be a positive 3. That 3 right there is your remainder. This right here is your quotient, but you must write it as a quotient. So don't just circle 1, negative 4, 2, negative 3. You have to rewrite it. And they're 1 less power than the category they're in. So this is going to be 1x cubed minus 4x squared plus 2x minus 3. This is our quotient. A lot quicker, though. A lot quicker than long division. Which is why your bottom 2 examples are just using synthetic. Is everyone good with this screen? Do we need it up any longer? Let's just do these last 2 together really quick. So I'm supposed to do f of negative 2. With synthetic division, you just take the negative 2. Remember, f of negative 2 really is x plus 2 if I was doing ordinary division. But I'm using synthetic. Since I have x cubed, I need to have an x cubed category. I need to have an x squared, I need to have an x, and I need to have a constant category. With this function, we just have 1x cubed, and everything else would just be zeros. Because it's just x cubed. There's just 1x cubed before f of x. Drop that 1 down. We do negative 2 times 1 gives me a negative 2. 0 minus 2 is a negative 2. Negative 2 times negative 2 is a positive 4. 0 plus 4 is 4. Finally, negative 2 times 4 is a negative 8. 0, that's my 8. This right here is my remainder. They just asked me what does f of negative 2 equal, so we just do f of negative 2 equals a negative 8. All right, one last one. We're doing g of 4. If I was doing ordinary division, I would divide by x minus 4. But since I'm doing synthetic, I'm just going to take that 4 out. Set up my synthetic. Go, okay, I have x cubed is my biggest power, so I need to have an x squared. I need to have an x, and I need to have a constant. Well, we have 1x cubed. We have negative 3x squareds. We have 5x's. Negative 12 for our constant. We're going to drop that 1 down. We're going to do 4 times 1 will give me 4. Negative 3 plus 4 is 1. 4 times that new 1 that we have is 4. 5 plus 4 is 9. And finally, we have 4 times 9 is going to equal 36. 36 minus 12 is going to be 24. That is my remainder, so that is also my solution. So g of 4 equals 24. Any questions on synthetic division or ordinary division? It is a lot of information as per usual. We do have a test next Thursday. Your homework is pretty straightforward. The only one that's kind of a gotcha moment is number 5. Number 5 is slightly different with ordinary division. Number 5 is going to be slightly different with ordinary division because it is s squared.